Let's go ahead and take a look at some basic derivations in calculus. Basically, some properties of derivatives, considering the rules of them rather than taking their limits. So, the first rule you can think about is taking the derivative of any real number or any rational number. So if y is equal to f of x and it's equal to c, which is like a constant number, and if c belongs to all rational numbers, then by taking the derivative of anything that is a constant number, you always get 0. So the y prime, or the derivative of y with respect to x, is always going to be 0. For example, if you take the derivative of 2, the y prime is going to be 0. The second rule, or the second property of derivatives you can think about, is if a constant number is being multiplied by x, so k times x, where k belongs to all real numbers. In such a scenario, the derivative of this function is going to be y prime, or dy over dx, and it's going to be equal to k. So for example, if you're taking the derivative of y equals to 2x, y prime, or dy over dx, is simply going to be 2. Let's go ahead and take a look at the next rule. Now, if you were asked to find the derivative of any function of x that has a power, like x to the power of n, where n belongs to real numbers, the rule for this type of derivation is y prime equals to n times x to the power of n minus 1. So you basically bring the power of x down, and then as you do that, you essentially go ahead and subtract 1 from the power. For example, y is equal to x squared. Well, here's what you're going to do. You're going to write that as 2 times x to the power of 2 minus 1. So the derivation, or y prime, is simply 2x to the power of 1. Let's take a look at rule number 4 now. Let's say, for example, you're giving the function that has a power, so x has a power, but it also has a constant number before it. So like y equals to k times x to the power of n, and n belongs to real numbers. Here, what you got to do in order to take the derivative, the y prime, is you just got to leave k behind, you bring n behind, and then you do as the rule 3 suggests. So you just kind of multiply n and k, and you times it by x to the power of n minus 1. So here, for example, if you were asked to find a derivation of 3x squared, the first derivative of this, or y prime, is going to be 3 times 2 times x to the power of 2 minus 1. So y prime is simply 6x1. Let's go ahead and take a look at another type of rule, or number 5. Let's say you have a function that is raised to the power of n. So y is equal to u raised to the power of n. Here, where u is simply equal to a function of f of x. So u is a function of x. In this scenario, in order to take the derivative, dy over dx, or y prime, by the way, if you are not really clear on what y prime and dy over dx is, that's just a symbol of showing the derivative, the first derivative of a function. So y prime is going to be n times u prime times u to the power of n minus 1. What does u prime mean? So that basically means you're going to have to take a derivative of the function you're given first, and then multiply it by the power of that function, and then write the same function and subtract 1 from the power. For example, let's say you're given y is equal to x squared plus 6x raised to the power of 10. So here, u is a function, right? N is equal to 10, and the first thing you got to do is you got to take the derivative of that function. So y prime is going to be the derivative of x squared plus 6x. The derivative of x squared plus 6x is going to be 2x plus 6. You can multiply this by the power, which is n, which is 10, times by the same function, subtract 1 from the power, so 10 minus 1, the power would be 9. And there you go. This would be the derivative of the function y equals to x squared plus 6x raised to the power of 10. Let's go ahead and take a look at some other examples now. Let's say you're asked to find the derivative of something like y equals to 4 over x to the power of 8. Now, upon first glance, you might not really think about any rule that can be used to solve this question, but if you look closer, you'll realize soon that you just have to bring x to the power of 8 upwards, and the way you can do that is you can use the rule of negative powers. So you can write this function as y equals to 4 times x to the power of negative 8. And now you can use rule number 4 to take the derivative of this function. So y prime is going to be 4 times negative 8 times by x raised to the power of negative 8 minus 1. So here y prime is simply going to be negative 32 times x raised to the power of negative 9. And you can even write this as negative 32 divided by x to the power of positive 9. Let's go ahead and take a look at another example. Let's say you're supposed to solve y equals to, you're supposed to kind of take the derivative of x squared plus 4x plus 9 raised to the power of 2015. So in order to take the derivative of this function, you have to use rule number 5. So y prime in this scenario is going to be the formula. I'm going to rewrite it one more time. It's going to be u prime times n times u to the power of n minus 1. So y prime in this scenario is going to be the derivative of the function on the inside of the brackets. So that's going to be 2x plus 4 plus technically 0 because the derivative of 9 is 0 times by 2015 times by the same function but subtract 1 from the power. So x squared plus 4x plus 9 raised to the power of 2014 because I subtracted 1 from the power. And you can also rewrite this without the 0 because that doesn't really make a difference. So what we'll do in these calculus videos is, as you can see, I'll go ahead and I'll teach you about the properties of these derivatives. One by one, we'll learn about different rules. There's about, you could say, 20 rules that allows you to solve many derivations of different functions. That is usually suitable for not only A-levels, but also IB high-level math. After that, we're going to go into their applications. But for now, we can call it a day for this video. Stay tuned for the other parts. Take care and bye for now.